In this lesson, we're going to learn how to graph quadratic relations from an equation that we then use to create a table of values. So standard form of a quadratic relation is y equals ax squared plus bx plus c. So this is a format we looked a lot at in our last unit. So quadratic relations, they have a quadratic term, which is a term that is squared. And so the ax squared term, this is the one that is squared. So we're going to take a look at some different examples. So here we have y equals x squared. So we have a 1x squared, our a is 1. And we have a 0 for our bx and a 0 for our c. So we don't have anything else here. So just y is equal to whatever x is squared. So I'm going to solve for my y values in here. I have x values here from -3 to +3. So to solve for y, I'm simply going to substitute in my value of x. So when x is -3, I square that. -3 times -3 is equal to 9. So my y value is 9. When x is -2, I square that, and that is equal to 4. -1 squared is 1. 0 squared is 0. 1 squared is 1, 2 squared is 4, and 3 squared is 9. So now I have my table of values. So my first point, when x is -3, y is equal to +9. So x is -3, 1, 2, 3, and +9, so up 5. 10 is here, so down 1 from there. When x is -2, y is equal to 4. When it's -1, y is equal to 1, 0, 0, and 1, 1, 2, 4, 3, 9. So we have a vertex here. We have our parabola shape that we just learned about, so this U-shaped, and where our parabola turns, that turning point, that is our vertex. So our vertex is over here at 0, 0. So we have our vertex. Our axis of symmetry is an imaginary line that goes through the vertex, so over here. And our equation for that would be x equals 0. So we'll just label here that this point was our vertex. And in this case, we only have 1, 0. We have 1, and it is also the vertex. So because the vertex is sitting right on the x-intercept, that is our 0. So the point 0, 0 is both our vertex and our x-intercept, or our 0. So over here, I won't graph all these for the sake of time, but we will do a few different questions where we look at how to substitute in values for x to solve for y. So this equation, y is equal to -x squared. Now because the negative is not in a bracket with the x, it is only the x that gets squared, and then whatever that is multiplied by -1. So remember that when we don't have a number in front of x, we could rewrite it as a 1, and because it's negative here, it's a -1x squared. So that might make it easier for you to see that over here, x is -3, so I'm going to substitute that in. So this means -1 times whatever x squared is. So I have -1 times -3, which gets squared. Bedmas tells us that we square, we do exponents before multiplication. So -3 squared is 9, and 9 times -1 is -9. Then I have -1 times -2 squared. So -2 squared is 4 times -1 is -4. And we can keep going. So -1 squared is 1 times -1. And anything times 0 is just going to be 0. So 0 squared is 0 times -1. We can still write it in though. -1 times 1 squared. 1 squared is 1 times -1. 2 squared is 4, and then times -1 is -4. And 3 squared is 9 times -1. So this one, we're going to end up with our parabola looking very similar to the first one, only instead of positive y values, they're negative. So we're going to see it from over here going up and down. So our vertex will be the same, our axis of symmetry will be the same, and our 0 is the same. But in this case, our parabola is going to open down and have a maximum, whereas in the first one, our parabola was opening up and had a minimum, which was the vertex. Okay, so this next question we have y is equal to x squared minus 6 times x plus 5. So for each question, whatever x is, I'm going to square it, then I'm going to subtract 6, multiply it by x again, and then add 5. So this is going to be the same all the way down. We're just going to have different values of x each time. Okay, so this is the exact same equation here. Instead of writing an x each time there was an x, I'm writing brackets, and then whatever my x is here, that is what I'm going to substitute in here. Here my x is 1, and then 2, 3, whoops, 4, 5, and this last one, x is 6. So 0 squared is 0, 6 times 0 is 0, 0 minus 0 is 0, and then plus 5, so y is equal to 5. 1 squared is 1, and then I'm going to subtract 6 times 1, which is 6, and then add 5. So 1 subtract 6 is negative 5, negative 5 plus 5 is equal to 0. 2 squared is 4, 6 times 2 is 12, so minus 12 plus 5. So 4 minus 12 is negative 8. Negative 8 plus 5 is negative 3. Whoops, looks like I've missed putting my squares in here. Okay, so then we have 3 squared, which is 9, minus 6 times 3, which is 18. 9 minus 18 is negative 9, plus 5 is negative 4. 4 squared is 16, minus 6 times 4 is 24, plus 5. So 16 minus 24 is negative 8. Negative 8 plus 5 is negative 3. 5 squared is 25, minus 6 times 5, which is 30, plus 5. So 25 minus 30 is negative 5. Negative 5 plus 5 is 0. 6 squared is 36, minus 6 times 6 is 36, plus 5. So 36 minus 36, 0. 0 plus 5 is 5. So there is our table of values that we're ready to plot. So once again, we take our equation, we can rewrite it. Instead of any x, we can write a set of brackets, and then inside that set of brackets, we substitute in the value for x that is in that row of the table. Then we will evaluate that expression and find the answer, and that's what y is equal to. So let's plot this one. We have when x is 0, y is equal to 5. When x is 1, y is 0. When it's 2, y is negative 3. At x is 3, y is negative 4. At 5, it's, whoops, what did I do here? Sorry, at 4, it's negative 3. At 5, it's 0 again. And at 6, we're up at 5 again. So we have our vertex. It's over here. That's the point 3, negative 4. We have our axis of symmetry. Happens at x is equal to 3. Our zeros are over here. We have 2 of them. So we have 1, 0, and we have 5, 0. Those are our 2 zeros. Oops. So if we look over here, when y is 0, those are the zeros. Our vertex is that one point that is the only y value that's the same. So we can see here we have a y of -4. For -3, that happens when x is 2, but also when x is 4. And 5 happens when x is 0, but also when x is 6. And then our zeros as well. Y is 0 when x is 5 and when x is 1. So for every value of y, there's 2 values of x that have that same value of y, except for the vertex. So that's the one that's a single point. It's a turning point. It's right on the axis of symmetry. For any of those other points, what we can see is that from the axis of symmetry, they're the same distance away. So these 2 points here at a y of -3 are exactly 1 away from the axis of symmetry. The zeros are exactly 2 away, and up here these are exactly 3 away. So that is because our quadratic relations are symmetrical about the axis of symmetry. Okay, so we have another question here. I won't go through this whole one, but to get it set up, we'll do the same thing. So I'm just going to start from the second one here. So we have -2 times whatever x is, which will get squared, -4 times whatever x is, and +6. So I'll just do one example here. So our x in this line here that I'm doing is -3. So -3, we would square that first. That's 9. -3 times -3 is 9. And 9 times -2 is -18. And then I'm subtracting 4 times -3, which is -12. So I'm subtracting -12. That means I'm really adding 12. And then I have +6. So 12 plus 6 is 18. -18 plus 18 is 0. So there's a point there. So we would do the same thing all the way through this exact equation, but we keep changing out what x values we have. Okay, we'll take a look at a couple examples where we don't have to graph. So when we're working with graphs of quadratic relations, sometimes we can identify key features like the vertex, axis of symmetry, direction of opening, max-min values, and zeros without actually having to have a graph or a table. We can just look at words that are written down. So Mr. Smith kicks a soccer ball across the field. It lands after 7 seconds and reaches a maximum height of 3.5 meters. So sometimes it can be helpful to do a quick sketch. So when he kicks the soccer ball, it's on the ground and it lands again 7 seconds later. So it would be on the ground again. So this would be 7 seconds in. This would be at 0 at the start. And so the soccer ball is going to soar up and then come back down. So our vertex is going to be exactly halfway in between because we have an axis of symmetry here. Now halfway in between 0 and 7 is 3.5. So the vertex would happen at 3.5. And it says that the maximum height that it reaches is also 3.5. So both our x and our y values for our vertex are 3.5. The axis of symmetry is halfway there, so x equals 3.5. This opens down. That means we have a maximum. And our zeros happen at 0, 0 and at 7, 0. So at the beginning and 7 seconds later, the height of the ball is 0. Okay, let's try this next one. A model rocket takes off at 8 a.m., rises to a height of 1,000 feet before returning to the ground at 8:15. So we can call this time is equal to 0, and this is time is equal to 15 minutes. So from 8 o'clock to 8:15, that is 15 minutes later. Now this height here is 1,000 feet. A vertex would be reached, so because things are symmetrical, it would be reached at exactly the halfway point, which would be 7.5 minutes later. So our axis of symmetry occurs at x equals 7.5. Our vertex, so the x coordinate of our vertex is 7.5, and the maximum height is the y coordinate, which is 1,000. The direction of opening is again down, which means once again we have a maximum, and our two zeros are 0, 0 and 15, 0.